All right. So today we're going to analyze submerged surfaces. So I'll go through quickly how we do it, which is very similar to what you have been doing. And then we'll go through a practice problem that I actually did in PowerPoint step by step. And I'll post that for you. So you can either take notes or you can wait for it to come up. All right. So here we have this is something like a container or something. We have water up here as our free surface. And then we're particularly looking at this little square rectangle. Maybe it's a window. Okay? All right. And we want to figure out what the hydrostatic force is just on this. So it's submerged and it's at an angle. So you do everything we've been doing the same. All right, so if you recall, what would the hydrostatic resultant force be? What two variables do we use? P average times A, and then what was P average? Rho GH C. Yep, remember that, yep. And why don't we, how come we don't worry about atmosphere? Well, atmosphere actually acts on the left of this plate, and it acts on the right side of that plate. So you don't have to. Okay? Then, this hydrostatic force will act perpendicular to that surface, but we know that it's not at the center location because we know that the pressure distribution is weighted. So it's a higher pressure down below here, and so this hydrostatic force actually acts at the center of pressure. So this is what we want to label. Oh, I'll do these arrows here. I'll do them in orange. So there to there, and then something like this, where this is HP, and this one's HC. Label this FR. And then we're at an angle, so what coordinate system should we now do? The y direction, yep. And that's perpendicular to the surfaces. And I might as well do these in purple. Oops. And this one. So this would be YC and YP. And that is your direction Y. And say this is the angle there. And if you remember, HC would be YC sine theta. HP is YP sine theta. And YP is YC plus IC over YC times A. So it's the same stuff we've been doing. The only thing now you have to worry about is you have to figure out this extra distance from the free surface down to where you're starting to work at. That's the only difference. Okay? You just have to add that in. Yep. So when you upload this, I would highly recommend doing the presenter view, because it will, then you could right click and go step by step by step like I'm going to do today in lecture. Okay? So here is we're going to find FR in the center of pressure on this rectangular plate right here. Okay, so this is a container, and say there's a window here, and we're going to fill it with water, or this actually isn't water, right? It's something different because it has an SG different than 1. All right, so sure, mercury, whatever you want, doesn't matter. Okay, but in here we have a liquid. And we want to find the resultant force of the liquid, the static force, due to that on this window. Okay? So what I did first is I said, okay, let's just take this section, which is here, and I made a horizontal line across. All right? So what I'm trying to do is figure out my y direction. So, did I show you those dimensions? Do I have this on? It doesn't work. Let's see if I go next. Yeah, there we go. For some reason this doesn't want to clip, but that's fine. Now, you see that this window is at an angle of 20 degrees, and it's 0.76 meters from the free surface down. So what I did here was I drew a horizontal line at the free surface up top. Then I drew this red line straight down the angle that this window is. So if I do this, from the free surface straight down to the right, that's our centroid location of that window. If I go down a little further, we don't know exactly where it is, but it doesn't matter. As long as we label it HP, that's our center of pressure. So far, everyone's okay? Following along? So I labeled the centroid, I labeled my location of center of pressure. Now I know it's at an angle, so this is where I'm going to start doing my y direction. So I make this line right here, which is perpendicular to the red line. Then I label my YC and my YP values. Questions so far? What I want to do now is we want to find YC. So YC is, again, from the free surface, so from this point all the way down to where my centroid is. All right, so let's go through this. So YC is from this free surface straight down, which we call H1, and then we're going to add half of this length of this rectangular section. Okay? Now, how do we find this value right here? Well, do some algebra and some trig. This was the angle that was given, and if you do your algebra and trig, you would find that this right here is theta 2. All right? So this distance from the top of this rectangular window to the free surface was 0.76 meters. Here's our angle, and we're looking for this. So what I did was I did cosine of the angle. So cosine of 0.6 meters divided by your hypotenuse, you can rearrange and solve for your hypotenuse. So you get 0.809 meters. All right, now we could then add half a meter to get our YC value. Zoom in. Huh. Look at that. Better? Okay. Can I zoom in again? Nope. Oh, but that's cool. I can actually zoom in to certain sections. All right, we found YC. What's the next step that we need to find? Why we need H? Okay, before we need to know HP, HC, because we need to find the average pressure with HC. So Does everyone have this? I'll zoom into the equation here in a minute. So what we want to do now is we want to find HC. All right. So I know my identities. If this is the angle here, that would be the angle there. And I use trig again. So cosine of the theta equals HC over YC. And I can then find my HC. If you notice, this is different, right, than what I've been writing, because my angle is at a different location. So you want to make sure that you use the correct. Is it cosine or is it sine? It's not always going to be one or the other. It always depends on how you set the problem up. I think this we already had. So let me just zoom in onto this section. Now we can then draw our FR, which is located at YP, perpendicular to that surface, and then start our equations that we've been starting. So FR equals P average times A. So your average pressure, P average, is rho G times HC. Should have made that a subscript. Sorry. And then what I did here, this goes on to the next line, just to save some space. So your density is your SG times density of water, which is 1,000, times gravity, which is 9.81, and then I multiplied by our HC that we found. So this whole equation is one line right here. But I didn't want it to run over the sketch. I think I found the area down below. The area is just the width times the length, because it's a rectangle. What's the area of a triangle? Half times base times height. Yep. And oh, look, I did it up there. Perfect. Now we can find the hydrostatic force. Multiply our average pressure times the area, we get about 5.8 kilonewtons. Is finding YP. And this is where you need to figure out your IC. All right, and this depends on a rectangle, it depends on the shape, right? All right, then we find our YP. I think that is it. So your location is 1.29 meters from the free surface down.